what is a computer? There are many ways that a person might try to answer that question. Obviously, some ways are more effective than others. I'd like to come at this question by way of three other questions. Three questions that we ask about lots of the things around us in our world. First, I would like to ask, what does a computer do? Secondly, what is it comprised of? And thirdly, what can be done with a computer? If we can answer these three questions, then we'll have done a pretty good job at getting to the heart of what a computer itself really is. So let's look at the first question. What does a computer do? Now, in my experience, it's useful to look back at the first computers, see what they did, and then use that to try to understand what modern computers do. So let's do that. This is a clipping I've taken from a Wikipedia article. And as it points out, the term computer has been in use since as far back as 1613, at least that far back. And at the time, it meant one who computes. So we immediately learned that computers used to be people. And these people are described here as someone who's supposed to be following fixed rules with no authority to deviate from them in any detail. So a human computer then, or at the time simply computer, was someone who followed a set of instructions perfectly in order to carry out a task or calculation. So mapping this forward to modern computers, then we could modify this sentence to say simply that a computer is a machine that follows a set of instructions perfectly in order to carry out a task or calculation. Now, this might seem like a pretty broad description of what a computer is, a very high-level view of things, but there's actually a lot of power in understanding this simple point, that a computer is simply a machine that is following instructions. It's not thinking, it hasn't got freedom of choice. It's simply applying a fixed set of rules that were given to it to a set of data that it's receiving as input. Okay, so let's look at the second question. What is a computer comprised of? So we look at things in our world this way all the time. If you're trying to describe a car to someone who's never seen one, you might talk about an engine and wheels and so forth, the parts of the car that are necessary in order for it to perform its duty, to perform the task that it's intended for. Similarly, we could analyze a computer and how it works, the things that are needed for it to work, I should say, and gain some understanding about what a computer is. So to do this, let's again look back at the original computers. These are human computers who worked for NASA several decades ago. Now, they aren't operating in isolation. You can see that they're in a room and there's a lot of equipment and so forth. And it shouldn't be too difficult for us to realize that a person acting by themselves doesn't make a very good computer. They need their equipment. They need the necessary supplies and so forth. And so let's look at this picture and try to analyze it and figure out what are the things that a computer is actually consisting of. Obviously, there's a person involved. And so let's put a diagram over here on the other side of the screen there, where we'll try to catalog the different pieces or the different parts, if you will, of a human computer, meaning the things that are necessary for a human computer to function. So again, there's the person. And this is the piece of the human computer that's in control. It is the part that makes decisions. It's the part that, and maybe makes decisions isn't the right phrase here since we just got done saying that they don't make decisions. But this is the component of the human computer that's in control of the process. It's making sure things are done properly. Maybe that's a better description. Okay, now secondly, I noticed this machine in the front of the desk, and so I want to draw attention to that now. This is called a Friden machine, and we can think of it as a basic calculator. And so these machines were used to help perform arithmetic. So the person who's working as a computer didn't have to do everything in their own head. They could leverage this machine in order to offload some of the work. And so we'll add an arithmetic unit to our diagram. Okay, now notice this box here on the edge of this person's desk. It looks to me like there's a label on it that says in. Whether or not that's the case, we're going to assume this is an inbox. An inbox is obviously not a new idea. but it's one that continues to be useful. People use inboxes in order to organize and control the way that information and tasks are delivered to them, as this person is doing. And so we'll add an inbox, see what I did there, to our diagram of a computer. Now, in a similar fashion and for similar reasons, we'll add the notion of an outbox to our diagram. We'll assume that there's a box behind this person we can't see on the desk, and that this is the method that's used to get information and jobs out of this computer space. So we'll add that to our diagram. And then finally, I'd like to draw your attention to this substance that we see throughout this picture. And of course, this is paper. And note what's being done with this paper. So here we see someone who appears to be performing computation. Here someone looks like they're looking through data that's already been recorded on some paper. And then here in the back, there's a filing cabinet filled with paper. What's on it? Probably records and data that can be used at some future date. So throughout the picture, paper is an important part of the computing process. And what is it doing? Well, it's acting as a form of storage. It's a place where information and tasks can be recorded so that the computers can operate on them. And so this is an important piece of the puzzle when we're trying to consider how a computer worked when computers were human computers. So our diagram now has 5 parts, and we're going to say that these are the 5 things that must be present for a human computer to function. Now let's think about modern computers. Keeping in mind the fact that modern computers were intended to replace the humans who were performing these tedious and long calculations and so forth, it shouldn't be surprising to us that if we look inside of a modern computer, we'll find circuits with roles very similar to the different elements that we have isolated or identified inside of this picture. So, for instance, there is a circuit inside of modern computers that is called a control unit. And the control unit has a job similar to the job of the person who served as a computer in the past. Specifically, it's their job to see that the instructions, the task, are executed properly. Now, like the human in decades past, the control circuit doesn't have to do this on its own. It's able to leverage something called the ALU, or arithmetic logic unit. And this is very much like a simple calculator that can be used to perform calculations, to perform arithmetic as needed in working through the instructions that are provided to the control unit. Now, as with humans working as computers, modern computers need a way of getting information in and out and controlling the flow of that information. The simple scheme of using a box to organize things in the past suggests that maybe this shouldn't be a super complicated task, but that it's still one that's very important. And similarly, the means by which input gets into a computer and output gets away from it generally comes down to a pretty simple thing: a set of wires. A set of wires carrying digital signals into and out of the machine. Now, we're simplifying things a little bit. Obviously, there's circuitry that needs to be in place in order to control the timing of that information and make sure that it's being processed correctly and so forth. But ultimately, it really is a set of wires coming into and out of the machine that makes it possible for information to get into and out of the machine. Okay, finally, our modern computers, like computers of the past, must have a way of storing data. So instead of using paper or clay tablets or anything of that nature, we use one or more technologies, of which there are several, in order to create what we refer to as memory now. Memory has the same role as paper. It's used to store information and to act as a scratch pad, if you will, while we're performing computations. Our modern memory is much faster and takes up less space than the paper of the past, but it's fulfilling the same role. Okay, and so these 5 pieces then make up a modern computer. So in answering the question, what is a computer, we might say that a computer is a machine comprised of a control unit, an arithmetic logic unit, input and output circuits, as well as memory. Okay, on to our last question. What can be done with a computer? In short, anything. Well, with an asterisk, of course. What do we mean by anything? Well, it turns out that we think that any task or process that can be described precisely, meaning any task or process that can be described as a set of discrete, unambiguous steps or instructions, we believe that such tasks can be performed by a computer. Now, it turns out that this is very difficult to prove. But in many, many decades of trying to find counterexamples, no one's been able to find one. You cannot describe, or rather no one has been successful in describing precisely a task that we can't build a computer to perform. And that is pretty significant. I should point out that when we throw in words like discrete, unambiguous steps, and so forth, that precludes words like understanding or love and things like that. So that's not what we're talking about. What we're talking about here is, for instance, calculations that need to be performed, tasks that can be performed physically and can be described in steps. Any such set of tasks, we believe, and we're pretty sure of it, that we can build a computer that can perform those tasks. Okay, so let's recap. What is a computer? We've come up with 3 answers to 3 questions to answer this question. Firstly, a computer is a machine that automates computation by following a set of instructions perfectly. We should note that we often refer to that set of instructions as a program. Secondly, a computer is a machine comprised of 5 main parts, specifically a control unit, an ALU, input, output, and memory circuits. And finally, a computer is a machine that can be programmed to perform any task that can be described precisely. These 3 statements, or sets of statements, offer a pretty broad view of what a computer is and raise some pretty interesting questions. Our answer raises questions. That's pretty typical, actually, if you think about it. We might find ourselves asking, okay, but how does one program a computer? Or how do the circuits that serve as the control unit, the ALU, and so forth actually work? Now, those discussions are beyond the scope of this particular video, but they're good questions, and I encourage you to pursue them, to utilize resources that are or will be present on this site to try to find answers to those questions to your satisfaction. Thank you.